Hi guys, so this is the tutorial that talk about in the Typhlo group on Facebook about targets and custom properties, and we'll have filters as well, but if you want to know more about filters, I already made a tutorial. It's already on We Visualize It YouTube channel. So this is what's happening in this file. I'll just press play, and as you can see, the sort of flying saucers abduct these spherical cows from the ground, and once the cow is nearby the flying saucer, they go away. This is a behavior that it's you can see it's more typical of rule-based particle system like thinking particles, but Typhlo has some features, some characteristics that allows us to do some sort of rule-based behavior as well. What's going on in here? So the spheres find the target, just a single one. And if a flying saucer is targeted by a sphere, it cannot be targeted by the other ones. And as soon as they find the target, the flying saucer is told to slow down, and as soon as the flying saucer is almost at a halt, the find target kicks in, so the sphere tries to reach the flying saucer. As soon as it gets near enough, the flying saucer is told to go away in a random vertical direction. So this is a set of rules, and as I say, this is usually done in rule-based particle system, but again, Typhlo has some tools that allow us to make it behave like a rule-based particle system. Let me show you the flow, and then we'll redo it from scratch. So here's the flow. I'll try to explain it quickly. So this is the event that creates the flying saucers. This is the amount, .1 per frame, so it means 1 every 10 frames. We just assign their position to the Typhlo icon that we can see here. This speed along the icon arrow, some scale to size them properly. Sorry, let me go to frame 0 so it's gonna be easier to click on the operators. And there is something that I assign particle groups and then do some stuff in the operators. So you can see this symbol, it means those operators are filtered. On the other birth event, we have 50 spheres. I position them on this icon, and then I start event loop to find the targets one by one. And as soon as I find the target, I tell the flying saucer that it is being targeted, so it shouldn't accept any other sphere. It shouldn't be a target for any other sphere. So there is a one direction relationship between spheres and flying saucers. And then I do other stuff like telling this flying saucer to slow down, and etc, etc. So let's do this from scratch. I'll create a new TypeFlow. I'll hide the previous one. And we begin. Let's create the flying saucers. Discs, because I don't remember how you spell saucer. Sorry for that. So yeah, I give like an infinite end. So this is procedural. You can make it. It's gonna work. Sorry, let me turn off this and turn on this. This is gonna work until all the spheres are taken away. So if I just make the timeline more, I give more frames to my animation and I keep the simulation going, as you can see, it keeps on working. Now the flying saucers have not any spheres anymore, but as I said, this is completely procedural. So if I go here and say 100 instead of 50, for example, so we have 100 spheres. It's gonna go on and on and on, and I might need to add more. There it is. So as I said, completely procedural. Okay, back to, I'm gonna turn off those, hide this, turn on, unhide the second flow, and let's start. So one every 10 frames is okay, and we are gonna position them on this existing icon, and we're gonna give them a shape. Okay, and 3D reference node, I created already this cylinder. Let me set this to geometry, and let's have some speed as well along the icon direction. Okay. And we should have, there it is, we should have our flying saucers. Maybe let's scale them down a little bit. There we are. We can add some variation to the speed as well. Oh, it's already in there. I'm happy with this. So those are the flying saucers. Now let's make the spherical cows that are gonna be abducted. We want them to appear all at the same time, and let's start with 50. We can change this later if we want more, but we'll see. So position icon, and we're gonna give them a shape as well. A low res geospheres, okay. We display them as geometry, and we let's see, we change the scale a bit. It's a bit, I don't know why, but it's kind of slow and not responsive. I'll investigate. Okay, let's try to go on. So now we have our spheres, cow spheres, and our flying saucers. They fly on top of them. So what we want is each cow finds a saucer and gets abducted by it, and then the saucer goes away. This is the most simple version of what we want to obtain. Now, why I'm gonna set target from spheres to saucers and not the opposite. Why? Because it's easier, since I know that I want the spheres to fly to the saucers, it's easier because the find target operator has an option to use the target, the particle target as a target. Sorry for the convolution of this phrase, but it is easier to just set a target for the spheres and then make them fly towards the target. If it could be done in other ways, but it would be way more convoluted, so I'll just find targets from the spheres to the flying saucers. So the flying saucers will be targets for the spheres. Okay, so how should we do it? The very first thing you might want to try is just put a set target here and tell random, for example, and start using the target filters, and you just exclude this event so you know that the spheres will try to find a target in everything but this event, and the only other event existing is this one. So how do we know if they found the target? We just use on display data, get rid of label data types and BERT-ID, and just use line to target. We're using the channel target, as you can see in here. Okay, so sorry for this. When you have this kind of cache not available, you just go under cache and turn on custom float. So we don't have any targets because they are created at the same time, and this is happening like at the very first step of the particle simulation, and there is the particles are created at the same time. Let's see if I change the evaluation priority. This is 1, let's make this 2. So this should happen after this, should be evaluated actually after this. Let's see if at least one target is there. No. So it says that at step 0, those spheres cannot find one single target. Okay. Let's try to make this continuous, even if we know it's not going to work because it's going to change target continuously, but just for the sake of the tutorial and learning something. So we're going to make the line to target bright blue, and there you are. So multiple saucers are targeted by the same saucer is targeted by multiple spheres, which is something that we don't want, and it changes over time. So as you can see, the lines appear and disappear. That's because the set target is set to continuous, so it keeps on changing. As soon as there is one disk, it is the target for every spheres. As soon as there are 2 disks, it's set to random, so like half of the spheres target this one and half of the spheres target this one. Okay, so how are we gonna obtain what we want? Again, what we want is one sphere picks a saucer as a target, and that relationship is gonna be univocal and is gonna last until the end of the simulation. Let's set back the priority, evaluation priority as the same. So, as we can see, setting the target, the timing to continuous is not gonna work. So, let's make it uneven entry, and let's make a loop. The only way I know in TyFlow to make a loop is just make a loop of events, like sending out and then sending out again to the same event, so they do a circular motion between the events, and that's the only way I know to make a loop. So we send out all the particles as soon as they are created, so immediately, and then we split just the first. We set it to the first particle goes out and does something, like it tries to find a target. All the others get sent out, and again sent out again, back to the event. So one particle goes and tries to find a target. If it does, it's gonna do something. If it doesn't, I'll send it back to this event. All the others are sent out and then sent out again back to this event to be split again and blah blah blah, so the loop continues. I hope this is clear. It's not rocket science. I think it's quite clear, right? So one particle goes out and all the others go here and then back here. This is the if you guys know any other way to make a loop, I don't want to use scripting for this. I just I want to keep this only operators, no scripting. I think it's easier for beginners, and I didn't even try to think at a script solution, because this one was so simple. I just started it like this, obtained the result. Okay, so let's go on with the tutorial. Okay, so as we can see, I'm sending the first particle in here, and I wanted to find a target from the flying saucers. Instead of being random, I want it to be based on neighbors. So let's change this to from neighbors, so we can have a distance setting target. Now, target filters. Exclude this event doesn't fit anymore, because we have multiple events, so it could find the target where we do not want. We want just the flying saucers. So how can we do this? I can send this back to all the events, but filter them by simulation groups. So find a target only on the particles that belong to the simulation group number 1. And let's add a particle group in here. It's set to change the simulation group of the particles to 1. So now in here we can move this display operator that is going to show a line towards the target. If now let's say that the particle tries to find a target, the group is set, so the filter is okay, But what we want is also to be sure that it's gonna find the target in a radius. I know already that 100 centimeters is gonna work, but you just try by trial and error. And what happens if so this one is trying to set a target on the first step, but if it doesn't find it, I want it to go back to the pool and then split again and find target again. I want them to be looped until they find the target. So how can we do this? We're gonna use two send out operators. I'm gonna move this outside, and I want to enable a filter. So if the particle has a valid target and the target is target, if the particle has a valid target, send it to this event where it's going to be let's change those to geometry, copy and paste, and set it to bright red, for example. Okay. But what happens? So we send out the particle if it has a valid target. Don't mind this. This you cannot have a value for has a valid target. It's just one. It's just true. So it's filtered only if it has a valid target. This is a visual. Well, let's call it mistake, but it's not a mistake. Maybe Dyson is might change this, like in the property test, where you can actually give a value to the property of has a valid target, so it can be true or false. Right now is only true. So if it has a valid target, then this condition is okay and it's gonna work and send the particle to this event. Okay. If it doesn't, so we put an operator send out exactly below. If it doesn't, back to the looping event. Okay, I hope that you're following me here. So we split the first particle, let it try to find the target based on proximity, 100 centimeter radius, and the closest flying saucer it can find. If it finds it, this filtered send out is gonna send it here, because the condition it has a valid target is satisfied, so it's gonna be sent out. If it doesn't have a target, this is gonna be ignored, so it's gonna be sent out by this other one back in the loop. And this loop will, for every step, will test the spheres one by one until they have a target. Okay, so let's see what happens here. I'll just try and play the animation. Maybe the speed is even too slow, but yeah, as you can see, we're starting having targets. I raise a bit the speed of the flying saucer, the initial speed. Now we are having targets, but as I said, we want just one sphere for one flying saucer. So how to solve this problem? This is quite interesting, because we start using custom properties, and we'll get, as soon as a flying saucer is a target for a sphere, I want it to get out from the group of the targetable objects. So I want it to not belong anymore to group 1. How do we do this? First thing first, the particle found a target, so it's sent out here, and we know it for sure. We can see it happens with display data. We see it becomes red. We see this line. This is the target for this particle. So now it's time to tell the target to get out of the group of the targetable particles. This is the group, so group 1. I want this target to not belong anymore to group 1. How do we do this? And this is the funny part, because we realize that with custom properties we can make the two groups talk to each other. So we put a custom properties operator in here. Let's go to 0, so it's gonna evaluate in an easy way. So we want this custom properties to tell the target to stop belonging to the group. So the way I want to do this is this. I want another particle groups operator set to continuous, so it's gonna check for every step of the animation. Is gonna be always awake, and instead of set I want it to be put on remove, but I want some rules for this. If I leave it like this, it's just gonna get all the animation out of group 1 immediately. What I want is the filter, and the filter is gonna be a custom float that we're gonna set here. So as soon as we set a custom float on the flying saucers, this is gonna be triggered. So the value I want to change is on the target, the channel is target, and so the custom floats are like tags, and I just want to tag every flying saucer with a custom float that says, oh, I am a target, stop targeting me. So we're gonna give it a value. I'm gonna call it I try to give always some meaningful name to the custom float, so it's easy to get lost. So the flying saucer now knows he is a target. I'm gonna set this value to 1, so it's true, and this is gonna happen as soon as it is a target. And so I want to filter this. Oops, sorry. A custom float that is exactly equal to 1, and it is this. Let's see if this works. Oh, sorry, let me increase the speed. It's really taking a bit too much. Like 3 centimeters might be better. Yeah. As you can see, as soon as they are targeted, no other sphere is targeting them anymore. So the big part of the job is done. This might seem convoluted, but actually make the particles talk each other is really easy. As soon as they are targets, you can tell the target to do whatever you want. Because now with filters, we make the operators work only if you can actually combine filters with AND or booleans. This is how I made this is how we're gonna make also the flying saucers slow as soon as they are targets. So let's continue. We know this is working, and it was quite easy, right? I mean, all the magic happens here. We might rename this with a proper name. Okay. Now I want them to slow down as soon as they are targeted. We copy, since a few versions we can copy the particle filters, and we just pass them. So this slow operator is gonna slow down the flying saucers only when they are a target for the spheres. Again, let's play and see. Yep. Working perfectly. As you can see, there's only one line for each particle, so it's we can actually investigate this more not only visually, but we can literally see that they don't belong anymore to the group. So if we set the particle groups, you can see that they're in group 1, but as soon as they're targeted, they don't belong anymore to any group, so they cannot be targets anymore. Watch closely. Group 1, not a group anymore in the very next step. Okay, and now it's just a matter of we know how to do these things using filters and custom floats. We can start the abduction, so the spheres are gonna go towards the flying saucers, and as soon as they're close enough, the flying saucers will fly away. The method is absolutely identical, so setting the custom floats as soon as something happens, set a custom float, and then filtering by the custom float, and operators will work if that condition is reached. This is, in my opinion, literally a rule-based behavior. So let's go on. We add a find target operator, and we're going to use particle target, channel target as a target. So let's see what happens. Oh, let me get rid of this display data. Okay, so as soon as they find the targets, they go towards the flying saucer. But this is not what we want, because we want them to start flying just when the flying saucer is almost at a halt. So again, what I want here is to investigate the flying saucer speed before the find target. When the speed is 0 or almost 0, this is gonna kick in. So let's tag our particles, our spheres, with a custom property. This is a value from the target that is gonna be written on a channel, on a self channel, on a spheres channel. Okay, So what we want to know is the velocity magnitude, for example, and we can write it on a target speed channel, and we're going to investigate for this. So as soon as it must be set to continuous because we want to continuously investigate the target speed. Let's disable the find target for now, and let's add custom float investigation in our data display. So let's watch the target speed. Okay, so as you can see, we have numbers going on here. So as soon as it is like 0.0 less than 0.01, for example, so there, even now it could be less than 0.1, start the abduction. Okay, we can get rid of this, and in the find target we add a filter. Test through if the property is less than 0.1, and the property that I want to test is target speed. So if target speed is less than 0.1, this operator is going to start working. Again, let's see if this works. There it is. We might want to tweak. I don't want this like yo-yo effect. Let's see. Let's make the speed like 3, for example. Some variation and some ease when it gets close. And .5 to test through. Let's see what happens. Yeah, it's slightly less bouncy. We could slow it down even more. But it's sort of okay, because right now, as soon as it gets close, I want the flying saucer to go away. Okay, so what I want to do is to tell the flying saucer that the cow is on board, and so it can start going away instead of staying still in there. In the test action, instead of sending out, we're going to increment a custom float that we're going to later send to the target, so the target will know it's now time to go to the home planet. So what's happening here? As soon as this test is true, so as soon as the sphere is less than 0.5 centimeters distant from the target, instead of sending out from here, as you can see, there is not anymore, I cannot take a line out of here and go to another event. Instead of sending out, it's going to write a custom float, and it's going to increment it, so it's going to be more than 0, which is more than enough for what we want. Now we have two ways. The easiest way to let the flying saucers know that they're ready to go is just set another custom float. Let me name this properly because it's gonna get confusing. So check target speed, and now yes, Okay, disk ready to go. We want to set this to continuous and to operate only if the target is found. So again, we add a custom filter. We want it to be greater than 0, and the custom float is cows on board. So if cow is on board, this operator is gonna write a property, a value on the target. Which value? We're just gonna name it ready to go, equal to 1. Okay. Let's go back here and let's say that we add a speed. We're gonna make it start only when this custom float is equal to 1. The custom float is ready to go, and the speed is gonna be particle Z should be okay with 50 degrees divergence, and let's say 1 centimeter, 2 centimeters maybe, and let's add some interpolation so it's not gonna be immediate with some variation, and this should be continuous, so it checks continuously if the condition is true. Let's see what happens. Okay, so abduction starts. They're not going. Oh, maybe we have the slow operator that is keeping the particles in there. So let's copy these filters, get rid of them, take the speed away. We don't need it anymore to be continuous. We can be on even entry, because what we're gonna do is I'm gonna send out the particles only when they're ready to go, set it to continuous, and send them here. Let's see if now it works. Let me investigate why it's not working. Sorry for this. So to investigate, we're gonna use display data. And see what's happening to the custom float ready to go. Oh, it's always 0, so it makes sense. This is not being written, so we can go back to the operator that should write it. Ah, my bad, sorry. The channel belongs to the target, so it's a value written on the target, and the channel belongs to the target. Okay, now it turns to 1 and starts going away. So geometry in here. Okay, the flying discs are going away, but the spheres are not following them, and we can easily see why, because the find target is set to work only if the target speed is less than 0.1. As soon as they gain speed again, this is going to stop working, which is fascinating because it shows how our custom rule system is working, even if it's not doing what we want. But we just are going to add another filter, and we say that as soon as a custom float is equal to 1 and the custom float is cow is on board, it can be greater than 1 actually, greater than 0, sorry. As soon as the cow is on board, if the cow is on board, keep on working. Okay? Yeah. Now, as you can see, it's still working. Some more speed in here. Like 5. And they go away. That's it. We might want to add some, for example, what we could do is a slow operator here and slow them as they get close to the flying saucer. We could actually, instead of adding this, we could actually, if we slow down the spheres while they get nearby the flying saucer, as soon as they are almost at a halt, we could link them to the target. Plenty of options here, just using filters and custom properties and whatnot. We can make TideFlow behave like a rule-based particle system. I hope you enjoyed the tutorial, and see you soon until the next time.